So in this video, we're going to talk about determinants of matrices, and then towards the end, we'll talk about another method of solving linear systems in which we will use determinants. So to get started, we'll talk about a 2 by 2 determinant. If we let matrix A be our 2 by 2 A, B, C, D, then the determinant of A, which will be denoted with the two vertical bars on either side of it. Almost looks like an absolute value, but it's not. We'll say that A, B, C, D is actually going to be A times D minus B times C. So it looks like there's almost, we cross multiplied to a certain extent. We took the A times the D minus the B times the C. Now, the big takeaway from this is that when you perform this and you evaluate the determinant, what you end up with here is actually going to be just a real number, just a scalar. So let's go ahead and look at a real simple example then. In the notes, you're given 5, -8, 2, and 3. Now, you'll be given something like this, and the instructions will be just to evaluate. And so it'll be up to you to understand that the vertical bars on either side does not represent a matrix, but instead, they're actually looking for you to evaluate this determinant. So to do this, we'll go ahead and we'll take a 5 times a 3 minus a -8 times 2. So that looks to be 15 minus a -16, or 15 plus 16, which equals 31. So there's your real number, and there's your 2 by 2 determinant. Okay, so in this one, now we're looking at a 3 by 3. So for 3 by 3s and larger, we'll use the technique called expansion by minors and cofactors. Now, for 3 by 3s, our goal here is to actually break this apart into smaller 2 by 2s. Now, when you start a process like this, you'll need to remember that all of the entries there are associated with a very specific sign. We're going to put together a sign chart. We'll start with a plus in the upper left-hand corner, and we'll alternate signs all the way through. So all the way through the 3 by 3, you'll have either pluses or minuses, and it alternates starting with the plus in the upper left-hand corner. These signs here, these essentially are your cofactors, and we'll use them just here in 1 second. Now, the first thing you'll want to do with this 3 by 3 is pick any row or any column, And so I'm going to kind of push our hand here a little bit and say, all right, we're going to use row 1. So by selecting row 1, we'll start with the -1 in the upper left corner. Notice how the -1 in that position corresponds with that plus that I have circled there in the cofactor table. The plus means to keep the sign the same. So we'll put the -1 down, we'll keep the sign the same, and then I'm going to have a 2 by 2 minor off to the side. Now, if I cross out the row and the column that the -1 is in, you can see that it leaves these 4 numbers. Those 4 numbers are going to be the 4 numbers that I put in the 2 by 2 determinant down below. So I've got a 2, a -3, a 6, and a -9. Moving on to the next number then in my row that I chose, we have a 3. That 3 is associated with that negative, which means we need to change the sign. So we'll have a -3, and then we have our 2 by 2. If I cross out the row and the column that the 3 is in, you can see that I would have a 0, -3, 2, -9 in the minor. So I have a 0, a -3, a 2, and a -9. And finally, off to the third entry in the row that we selected, we'd have a -1, and that sign would be the same because it's associated with the plus. And if I cross out the row and the column, my minor would be 0, 2, 2, and 6. So the expansion part just means we took a 3 by 3 and we expanded it out into smaller 2 by 2s. The 2 by 2s that you're looking at there are the minors. In the sign chart, though, those are where the cofactors come from. So now all we have to do is simplify this whole thing out. So I'll have my -1, and then I'll go kind of slow through this first one. We'll have a 2 times a -9 minus a -3 times a 6, then minus 3, a 0 times a -9 minus a -3 times a 2, minus 1 times a 0 and a 6 minus a 2 and a 2. So at this point, now it's just a matter of cleaning all this up, this arithmetic up. And when you do, you end up with a -14. So the determinant of this 3 by 3 that we started out ends up being -14. Now, I want to point out one thing to you before we move on to the next example. We were able to select any row or any column that we wanted to from the start. Now, having seen this done, you might be thinking to yourself, well, it might have been better to pick column 1 or row 2 because we would have had this 0 in here. And you're right. If we have an entry with a 0, then it'll be 0 times whatever 2 by 2 minor is left, and we know that the real number comes out of the 2 by 2, so 0 times a real number leaves us at 0, and we don't have to work so hard. So moving forward, the golden rule for these determinants is that if you're able to select any row or any column, pick the row or column with the most zeros in it. It'll save yourself quite a bit of work.